Right, good morning. This lesson is a shout out to Dylan's The Frostbite YouTube channel. But so there you go. Dylan is watching me teach this lesson. Anyway, here we go. So we are now up to US 18239 element for the series and parallel circuit. Apologies, we've got a bit of a mess here, but that's because I've changed an actual exercise and put in some other values. So we have got 9-volt battery, we've got a 560 ohm resistor, and we've got a 1 kilo ohm resistor. I'll just chuck it in there for consistency, and we have a 680 ohm resistor. These are in parallel, and that's in series with this resistor here. So what have you got to do? Well, there's a whole bunch of things, and we're going to chip away and see what we can get done. So firstly, we need to get the total resistance. Now that's the resistance that this battery, if you took the battery off and put an ohm meter here to measure what it would see. And that's one of the probably the trickiest things to sort out here, because how do you do it? We know that there's a special formula for parallel. Series is easy, you add things. Well, what we've got to do is we've got to get rid of this parallel thing. We've got to turn this parallel circuit into an equivalent series resistor. So I'm just going to go red here. Let's imagine that was a big fat chunky resistor there in series, all this red here. That was a resistor in series with this 560 ohm resistor there. Then we can add that to this. So the way we do that is we're actually going to find out what this parallel resistance is. Now there were two ways that you've learnt how to do that. So I'm just going to go R and put two parallel lines down there, which means for a parallel set of resistors is equal to, now the proper formal way the physics student should do it is go 1000, which is 1 kilo ohm, to the negative 1, or 1 over 1000, plus 680 to the negative 1, and that whole thing to the power of negative 1. Alternatively, you can also use the slightly mathematically less confusing method, and you can only do that when it's two of them though. You can't do it if there's more than two for this particular version, and you can do the product 1000 times 680 divided by the sum, which in this case is the sum of those two is, let's do it properly. I was going to do 1000 and 1680, which it is. Okay, and there you go. Put it in brackets so you don't do anything stupid. So let's, either way, it doesn't matter. I'm just going to, again, reinforce how you do it the way that you can see currently. So I'm going to go bracket 1, well, that's not, is that a bracket? Oh yes, I think my calculator is just dying. Anyway, let's see what happens. 1000 to x to the power of negative 1. That x to the negative 1's not pretty to look at anymore, is it? Plus 680, was it, Dylan? Yep, 680, the negative 1, and then that whole thing to the negative 1 equals, and we have 405 ohms. Three significant figures will be fine. So 405 ohms. Okay, so we have ourselves a big resistor here, a big chunky parallel resistor, which is in fact 405 ohms. So now this is going to be nice and easy. We can actually go total resistance. Total resistance is equal to 560 ohms plus 405 ohms, which equals, and we got, oh, there's already got an equals down here. Oh well, I'll get rid of that then. And we're going to go, so we're just going to add to that value the 560, which equals 965, if we round it, ohms. Okay, so that is the total resistance of the circuit, and it's quite important to actually know how to do that before you carry on. Right, in fact I might just pause at this point because otherwise the video is going to be super long. Okay, thank you.